Welcome to Faculty Forum Online, a program of the MIT Alumni Association, sponsored in part by MIT Professional Education. I'm your moderator for today, David Corcoran, Associate Director of the Knight Science Journalism Program at MIT. We welcome your questions during the chat. For MIT alumni joining us via Zoom, please use the Q&A feature at the bottom of your screen. For all others listening in on YouTube, you can add your questions to the comments field. Our guest today is Susan Murcott. She's a lecturer at the MIT D Lab. The D stands for Development Through Discovery, Design, and Dissemination. The MIT D Lab works with people around the world to develop and advance collaborative approaches and practical solutions to global poverty challenges. Susan Murcott is an environmental engineer with a focus on water. Susan teaches 2 classes for D-Lab on water, health, and hygiene, and on water and climate change. She's led MIT student teams to international destinations for research projects, and she founded the nonprofit group Pure Home Water in 2005. She's written over 50 professional papers and a book called Arsenic in the World, an international source book. Susan Murcott, welcome. Can we ask you to start by giving the alumni an update on your current and upcoming research projects?
I just need to unmute first. So my current and ongoing work is with Pure Home Water, the NGO I founded. I've been there in Ghana with student teams for 12 years, since 2005. And we have a filter factory there that produces a low-cost water filter. Prior to my work in Ghana, I worked for 7 years in Nepal. That work got somewhat sidetracked because of civil unrest there. But the work in Nepal was on arsenic contamination. More broadly, it was on the subject of water, sanitation, hygiene generally. But our long-term work has been the fact that we discovered arsenic in Nepal in our first trip, and then worked on evaluating ultimately 7 or 8 technologies and choosing the best among them, which was called the Kanchan arsenic filter. And so that work is ongoing and has been reconnecting with Nepal because of MIT's Nepal initiative. That's led by Professor Jeff Ravel and Aaron Weinberger, who's an assistant to the chancellor. And that initiative came about in response to the earthquake in Nepal on April 25th, 2015. So that's my kind of ongoing work, is that I have a long-term sort of love of and commitment to Nepal and Ghana. But my upcoming research, there are 3 different projects. One is called the 200 Cities Project, and it's a collaboration between myself at MIT, New York University, and World Resources Institute, an environmental NGO in Washington, D.C. And New York University has made a database of the largest cities in the world. I think there's some 4,300 cities in that database. And from that database, they've selected a sample of cities, a global random sample of cities. So there's a set of 200 cities, and they're going to be monitoring the water quality in those 200 cities. And I'm part of that effort. I'm also a consultant right now to a World Bank project that's modeling water and environment in Uganda in collaboration with the Ministry of Water and Environment. And finally, a new collaboration is with Dr. Vin Gupta of Brigham and Women's Hospital on water and climate. But I want to focus today on the water, sanitation, hygiene work. And hopefully I'll be invited back sometime in the future and be able to talk about water and climate.
A reminder to alumni to use the Q&A function on your screen to ask questions of Susan Murcott. You can ask questions anytime. We'll get to them during the course of this webcast. So let me start with a question. Susan, how does your work fit into the scope of D-Lab?
It fits in beautifully. D-Lab emphasizes what they call co-creation in design and creative capacity building in practice. It emphasizes collaborative work with low-income communities around the world. And basically, though I have taught in D-Lab since D-Lab was first founded, I taught the dissemination class, and so it was one of the first Ds in the D-Lab name. I have, for many years, I worked in the civil and environmental engineering department, but my emphasis in my own work has always been in low-income communities, as is D-Lab's. In addition, D-Lab is radically transdisciplinary, and so it's got a diversity that's hard for some other departments to match. If one checks, one will also notice that it has women that have achieved equity in D-Lab's management and in teaching. So it's really around 50% or more of women who are running and teaching D-Lab. And so that's a nice difference between some of the, the kind of lower percentages of women in the faculty in the engineering school where I was. And D-Lab has also got a special focus that it's decided upon in the years ahead, and water, sanitation, hygiene is one of those special focuses. So those other ones being energy and agriculture. So it's an excellent home for my work.
The World Health Organization has just released its first global assessment of water, sanitation, and hygiene, and it found that more than 2 billion people in the world still lack access.
Exactly. We're on the same page, David, because I actually brought a copy of it because it's a really important document and it was just released.
So did talk about that a little bit. What were your reactions, and how do you see yourself engaging with these issues?
Well, it's a great question, and I could spend an hour on that topic. But as some of you listeners may know, the UN has had a long-term commitment to reduce poverty in the world. And the rubric under which that functioned was called the Millennial Development Goals. And the Millennial Development Goals ran from the year 2000 to 2015. And we're in a new phase now. And this first report, this newly launched first report, is the introduction to this new phase, which will go from 2015 to 2030. And the goals as they pertain to water were to reduce by half the proportion of people who lack access to an improved water supply. And an improved water supply was defined based on the ability of people in all the countries of the world to go around and survey what kinds of water supplies they had. And so they didn't look at water safety because that would require a level of technical expertise to be able to test water quality parameters that not every country had. So they used an infrastructure measure so that you could have a clipboard and a checklist and say, do you have a rainwater harvesting system? Do you have a piped water supply? Do you have a dug well? Is it an improved well? And so it was that infrastructure improvement that was the basis and the kind of analogy to having safe water, not the safe water itself. And so we've progressed now by 2015 with a certain level of success with the Millennial Development Goals over the previous 15 years, to the point where now there's a kind of higher standard. And in fact, the first slides of my slideshow speak directly to that. So maybe I could go to those.
By all means.
Okay. So let's see if I can manage to bring up the slides. And here we are here. And let's see now. Okay, here, right? Oh, and I have to go here and share screen. And I have to also go over here, right? Have I done that right? One over All right. Are we seeing it? Good. So the first question I have for you, David, or for the audience is, how many people in the world lack a safely managed drinking water service? Do you have an answer to that, David?
It's a very large number, a surprising number. 2 billion?
That's right. That's right.
Yeah.
So back
And the whole population of the world is about 7.
Well, they're using 2015 as their baseline. So the population was 7.3 billion. So yes, and so that answer is 2.1 billion, and it's 29% of the world's population that lack a safely managed water supply. And by the way, a safely managed water supply is defined as located on the premises, so not necessarily in your home, but on your property, available when needed, and free from contamination. And free from contamination is defined as compliant with standards for fecal coliform, arsenic, and fluoride, 3 parameters only. And so for comparison, nationwide in the United States, under the EPA Safe Drinking Water Act, a minimum of 122 parameters are monitored. In the Massachusetts Water Resources Authority, Boston water system, we monitor for about 234 parameters. So this is a very basic definition of safety, but it's a higher level of attainment than improved versus unimproved water. You can imagine, for example, that if you go to Mexico City, you may not drink the water from the tap in Mexico City, right? And that's a pipe supply. So according to the Millennial Development Goals framework, that would be improved water. So check, you're good, right? But no, a piped water isn't automatically safe water. Okay, so the Sustainable Development Goal for water is measuring that. And so then the next question is, how many people in the world lack a safely managed sanitation service? And you want to venture a guess to that?
I'm going to guess probably it's in the same neighborhood, something like 2 billion?
No, it's actually much higher. It's about 4.4 billion people. So 60% of the global population. All right, and then the third question is, how many people worldwide lack basic hand washing facilities with soap and water on the premises? And the answer there is we don't know. All right, so we don't have global data yet for that, but we do have some regional data, and it ranges from Western Asia and Northern Africa, where 24% lack hand washing facilities with soap and water, to as high as sub-Saharan Africa, with 85% of people who lack that. And so, and maybe I should do, if you keep interrupting me with questions, I would welcome that.
Our first question comes from somebody named Anonymous Attendee.
Okay.
Probably not his or her real name. And it goes back to your opening remarks. How interdisciplinary is water as a topic of research at MIT?
Well, it's quite interdisciplinary because there are folks at MIT from civil and environmental engineering, from mechanical engineering, from earth, atmospheric, and planetary sciences, in the Sloan School, in the International Political Science Group, that are doing water and economics. So there are a lot of folks that do water at MIT. How many of them do it with each other is a different question.
Daryl asks, it sounds as though quality is a primary focus, but how do quantity concerns fit into your project?
All right, so let me just go back here. Where I gave the definition of what safely managed drinking water service means: located on a premises, available when needed, and free from contamination. The question was about quantity. Yeah, and so that's addressed by available when needed. In other words, you can have a piped water supply, but it can be only available for 4 hours a day. So that wouldn't qualify then as safely managed by this stricter definition under the Sustainable Development Goals, because it's not available when needed.
Talk about how people actually get water, get drinking water in areas where access is limited. How everybody needs water to survive.
Sure. Sure. Can you see the picture that's up there right now? Okay, so this is our project site, and it's just down the path a bit from our factory. And it's adjacent to a village of about 300 families. And people use this as their drinking water supply. And so the women and children, but worldwide, it's predominantly women who are the water carriers, are physically carrying the water. You can see in this picture a metal pail in the right background, and you can see a jerry can, a yellow jerry can, and you can see a plastic bucket. And so they use those available containers to carry that water back to their home. And that's how people do it. But I mean, there are other conveyances. People use bicycles, people use ox-drawn carts or animal-drawn carts. Yeah, more frequently it's women as beasts of burden.
They have to find a source of water that is not going to make them sick. And often that involves a great deal of carrying.
That's right.
Hours at a time.
That's correct.
And I've in preparation for this webcast, I watched a couple of the videos you've got up online, and you mentioned at one point that in a tap water world, the one that most of your audience lives in, it's very hard to imagine what it's like for people who can't just turn on a tap and get clean water. Can you talk a little bit more about what their life is like?
Sure. I'm going to back up and make it a little bit more complex. We have about 25 workers at our factory at Pure Home Water, and about half of them are women. The men have at least a primary level of education. A few maybe have gone to high school. And they speak English. English is the official language of Ghana, but none of the women speak English. All right, so that's the first step, is that can I even communicate with the women? All right, so when I communicate with them, I'm communicating through a translator who speaks Dagbani, which is the language, the indigenous language of this region. And they've worked for me and know me, worked for the organization, not for me per se. But they've known me for 12 years, right? And yet we haven't talked much. And from time to time, I take the time, get a translator, sit down and talk to them. And one of the questions I ask them is, you earn a regular income from the factory, which they are very grateful for. What do you do with that money? And the first thing they say is, school for my children, all right? Because even though there's public education, there's still school fees that they need to pay. And then second, seed for their husbands to plant. They're peasant farmers if they're not workers at the factory. And so seed for their husbands. And the third is food. All right. So clean water is not their highest priority. They could buy, for example, what's called sachet water, which is bagged water. There's a big industry in urban and peri-urban areas of what sort of could be called poor man's bottled water or poor person's bottled water. And it's in a plastic bag, almost like a Ziploc bag, but it's heat sealed. And it's 500 milliliters typically. And it's a hot climate, so you definitely need water, but you have to pay for it. So they could, conceivably use some of their money that they earn to buy water, but they don't, all right? It's lower on their list. But they definitely do consider treated water, like from our filter or from the sachet industry, as pure water. They call it pure water, actually, yeah. And so, and then there's the whole question about defecation and open defecation. And all of these villagers, the women included, are practicing open defecation. And for women, they are expected to defecate in the dark, all right, which is when they first get up in the morning. So when they get up in the morning before they walk to the factory for work, they have to feed their children. Most of them have 4, 5, 6, 7, 8 children. They need to do the cooking for their husband and for their children. They need to defecate and do any washing, and then they need to walk to work. Yeah, so life is hard. Life is really hard for these women and for the families.
Lots of questions pouring in from alumni, so I'm going to start taking them one by one. Can you talk specifically about some of the technologies you're seeing that can create potable water? This questioner, Larry, asks about creating potable water from brackish water and or reused water.
I'm not well qualified to answer that question. The brackish water is a kind of desalination question. It's there's folks and among them former students of mine that are working on that. But as far as low cost methods, it's a difficult subject. And my own expertise has focused on microbially contaminated water and chemically contaminated water for the bottom, 1 to 2 billion people. All right. So that's really where I've focused. And when you look at this picture again, you can see that this is a surface water and this is visually dirty. And you don't see animals here in this particular picture, but people share the water with their animals. And so there's definitely going to be microbial contamination in this water. And that is considered the largest problem worldwide in terms of drinking water safety.
You mentioned Nepal, and one of your videos deals with the problem of arsenic in the drinking water.
Mm-hmm.
And you and your colleagues, I guess, have developed a kind of low-tech but fascinating technology for making that water safe to drink. Can you talk about that a little bit?
Sure. We went to Nepal initially in 1999, 2000. At that time, it was known that there was an arsenic problem in Bangladesh. It was recently known that there were millions of people affected by arsenic in Bangladesh. But testing had not occurred in India on any scale at all, and none whatsoever in Nepal. And so my team came prepared to do 2 different activities. One was water quality testing, and one was treatment technology intervention, possible treatment technologies. And so the water quality testing team looked at microbially contaminated water, it looked at nitrates, and we tested for arsenic. And in fact, we found arsenic there, and it led to an effort over a several-year period to test a variety of different technologies. The technology that we developed, and I have some pictures that I could show of that, if I could, but it's way forward. Yeah. So should I just? Is that the best way to do it? Let's see. Yeah. Okay. So this picture is of the water testing that was done after our MIT team did its initial testing. Interestingly, we happened to stumble upon Nawalparasi, which is the biggest circle in the center, as a site that we worked in, and also Ratahat. And so we found high levels of arsenic, and not entirely surprising because Bangladesh is just to the east of this picture, and it's the same watershed. In other words, the Ganges River runs through India at the bottom of this picture. This is Tommy Nagai, who is really the person who invented the Kanchan arsenic filter. And you can see him standing in front of 3 or 4 biosand filters. Biosand filter is an antimicrobial household scale intermittent slow sand filter that was invented by a faculty member at the University of Calgary in the 1980s. And there were a few of these at the time we arrived in Nepal. and we used them to test for microbially contaminated water. But we also figured out a modification of the biosand filter, which involved adding small iron nails to the diffuser basin in the top, as you see in this picture. And when you add dirty water into the diffuser basin, it runs through and past the nails, and the nails rust. And the rust is an absorption media for the arsenic. And it's very effective because if you have cheap zinc plated nails, they will continue to rust for years and give new surfaces. So to cut to the sort of end of the story with these filters, we built a whole entrepreneurial network. We won a lot of prizes for this work. It also led to my writing a book on arsenic in the world, which is a reference book, and it has also led to not only work in households but in schools. So in recent 2014-15, we helped to install larger systems in 20 schools with money from Dubai Expo. Yeah, and so this has been one facet of my career over a number of years.
You also got a fabulous shout out in an MIT commencement address. I don't know if that was for the arsenic filter or something else.
I don't know. He didn't tell me he was going to shout me out.
And who was that again?
That was Matt Damon. And so I have somewhere here a video. Here we go. Now, how do we play this?
I know him anywhere.
For that. I mean, take water again as an example. People are always looking at some scientific quick fix for the problem of dirty and disease-ridden water, a pill you put in a glass, a filter, etc. But there's no magic bullet. The problem's just too complex. Yes, there is definitely, absolutely a role for science. There's incredible advances being made in clean water technology. Companies and universities are getting in on the game, and I'm glad to know that professors like Susan Murcott at D-Lab are focusing on water and sanitation. But as I'm sure she'd agree, science alone can't solve this problem. We need to be just as innovative in public policy, just as innovative in our financial models. And that's the idea behind an approach we have at Water Credit, at water.org, called Water Credit.
Perfect. So the reason I brought this into the conversation is because Matt highlights nicely the complexity of the water problem and the need not just for this on the science side, but also on the social side, on the financial side, on all these different other aspects. And if you can help me get to my slideshow again, I was trained by a wonderful mentor who was at MIT for over 50 years, named Donald Harleman. And I came to know him at the very end of his career when I was one of his last students. I graduated MIT in 1992, which was the same year he became an emeritus professor. And it was thanks to him that I'm here today, I'm sure, but it was he who introduced me to the subject of water and wastewater treatment engineering. And we began work together on centralized systems, on wastewater systems, and I was influential in influencing him to take the technology that we were working on for Boston, so harbor cleanup, and for some other large urban coastal area cities in the United States, and to work together for over 15 or 17 years on the application of this innovation to wastewater in megacities in the developing world. And so he had contacts around the world. I had the interest in gaining experience around the world. And so I worked in a number of cities around the world. And so this was the kind of beginning of the opportunity to do not just technical work, but a kind of more broader type of work that is become the hallmark of DLab and why it's a good place for me to be. After my years with Donald Harleman in 1998, I had an opportunity to attend something called the Second International Women in Water Conference in Kathmandu. And at that conference, there were women who walked 2 and 3 days to attend that conference. And they were coming to hear me because I was the woman engineer at the conference, okay, the sole woman engineer. And I had been working at this stage on megacity wastewater, and they were among the 1 to 2 billion people that we now know, don't have access and would not be able to afford the kinds of systems that were the beneficiaries of the tap water world systems or the flush toilet world systems. And so I was challenged by this experience to come up with solutions that would be amenable to their financial and social and educational situations. So that was the beginning of my work. And what I wanted to have time for, I don't know how we're doing in time, but I want to have time to talk. We're okay? To talk about some of the achievements of my students who are kind of carrying this work even further.
Sure. I'd like to ask you a question from Karen.
Sure.
That's related to this subject. You mentioned that the other areas of focus are agriculture and energy.
For DLab, yeah.
Yeah, and the question is, does the DLab collaborate across these focus areas? For example, to look at how agriculture affects water quality.
Absolutely, absolutely. I mean, DLab is a relatively small place, but we're interacting with each other from the various sectors. I mean, DLab has a humanitarian group, it has a wheelchairs group, it has a medical devices group, and we all interact. Think of it like a Cambridge University college, so we're all in it together. And so, yes, we're in conversations on a daily basis.
A question from Sarah about cholera. Do you work with that disease at all and preventing it? And if so, how?
Yes. Let me go to an example from Molly's work. I teach about the cholera epidemic, and I have done some work on cholera. My specific work, there was a cholera outbreak in Central and South America. It began in Peru in the 1990s. And I was very interested in understanding how the interventions for that cholera outbreak were ongoing over time. And particularly, I was there with students in 2004. So this was before the cholera outbreak in Haiti. However, I had worked in Haiti. Again, like Nepal, it was a country that I couldn't continue to work in at a certain point because of civil unrest in the 2000s, in the early 2000s. But here, Molly is a student of a former student who works with the Centers for Disease Control. And for the past 6 years, she's been working on a global WASH team, providing technical assistance for cholera and for Hep E in outbreaks in Haiti, South Sudan, and Iraq. Yeah, and so her work she's working on it on a day-to-day basis, whereas I have worked on it from time to time. Now, I should say that cholera and typhoid are not epidemics, but are not uncommon in our project area in Ghana, okay? Also, with the earthquake in Nepal, cholera has been a problem in certain locations.
A question from, sorry, one sec. A question from Sultan J. Referring back to that picture that we saw earlier in the slideshow, people in what looked like a very muddy pond getting their water. What steps specifically do you take to make that water clean?
So that type of water supply is very typical in northern Ghana. It's called a dugout, all right? And actually it's a kind of rainwater collection device, if you will. People dig out a hole, and then in the rainy season it fills up with water. There's a lot of clay in the soil, and so it doesn't percolate through, but it holds the water and it evaporates, obviously, and some of the dugouts dry up, but others stay through the dry season, and people can get water that way. And so each village has its own dugout, and all of them are considered unimproved or unsafe. You know, they're off the charts in the lower direction in terms of the Millennial Development Goals or the Sustainable Development Goals. So when we first arrived in northern Ghana, which is the poorest part of Ghana, and which we targeted specifically as an area of greatest need, we had by that stage developed a number of small-scale household systems that worked in certain places around the world. For example, we had studied solar disinfection with PET plastic bottles in Nepal. We had studied the biosand filter in Nepal and in parts of Central America. We had studied in Peru the chlorine disinfection approach that was used in response to the cholera outbreak there. And so we had those technologies sort of in our toolkit, as it were, and were willing and interested in bringing those to northern Ghana. But we quickly realized that a number of them, like chlorine or the solar disinfection, would absolutely not work with such highly turbid water. I once asked a water engineer who had a career in the Boston area what was the highest turbidity he had ever seen in his career, and he said 100. And our average turbidity of that type of water source is 600. So it's not able to be disinfected. You'd have to pour in just enormous amounts of chlorine. You couldn't disinfect with solar. And so we tried ceramic pot filters, which we had learned about from a factory in Nicaragua. And ultimately, that's what led to our building the factory in northern Ghana, is that it was a good fit for that environment. Clay was readily available. And you do have to clean the pot regularly to dislodge the particles that get trapped inside the pores, but you can rinse it out and scrub and reuse the pot time and again, and it's good for about 3 years. So that was the technology that fit for that region. Now, ideally, sure, there'd be a piped water supply for each village. That there already are hand dug boreholes that are giving safe water, but they're not always working through the dry season. And so people revert to the dugouts.
Chad asks, how much does one of your filters cost? And do you know how that translates into cost per liter of water? And does that make it more economical than the bagged water you were talking about?
It's definitely more economical than the bagged water. I can't give those numbers right off. The filter is $30, and the filter treats 10 liters an hour. But I don't have a comparison. It's a good question, and I should have that at the tip of my tongue, but I don't.
What about the change over time in water quality and water quantity in places like Ghana and Nepal? Are you seeing the situation get significantly better?
Yes, I am seeing it get better. It's a slower process than I envisioned when I first entered this field. And on the bright side, I wanted to highlight in the few minutes we have left some of the work of a few of my students, and it is very much of a bright side. So to start, a picture of 5 different students from 2001, the earliest, up to 2017 this year. And the first 3 students are were all Master of Engineering students of mine in the Civil and Environmental Engineering program, and the recent two are ones who took my Water and Sanitation D-Lab class. So with Nat, he's had the longest career at the World Bank in Tanzania and in Washington for 8 years, then a year in Charity Water, and currently Vice President of Strategic Partnerships at Safe Water Network. By his estimate, he has helped 3.6 million people in the course of his 16-year career. So when I see something like that, and I trust his numbers, I'm very proud of that, because I could say what I've done in Nepal and what I've done in Ghana, and it's a smaller number. It's hundreds of thousands at best, and it's over a much longer period than that. This is Nat in the back corner there. And then a few more. Rachel is the program director of an NGO called Aquia. Her research projects are involving monitoring safe water, basically testing government-regulated water quality throughout Africa, a willingness to pay study for sanitation, assessment of water safety plans in the Asia-Pacific region. I already talked about Molly's work with cholera and hepatitis. She's newly, in this past year, working on international infection control, including project manager for pilot projects designing novel medical waste treatment, developing a model to determine cost effectiveness of water and sanitation interventions, and providing technical assistance to the WHO on WASH for healthcare facilities. And then just to take an example from a D-Lab student, she's a Chinese woman who's founded an NGO called My H2O that is about extending access to clean water in China and training youth-led water testing network. She says, the idea came to me in a D-Lab class. We started looking at water pollution in China, which is just as critical, having already seen the air pollution problem in China and she having been involved in that before she came to MIT. So she started My H2O, and she's won an Ideas Global Challenge Award. She's won over $100,000 in an award from the National Geographic Air and Water Fund, and was recently named an Echoing Green Fellow. These are examples of her teams working in Dalian University and in Yunnan. And finally, DJ just graduated. He was a Harvard student who cross-registered in my D-Lab class, and he started something called WASH Mobile and his own NGO. And he won a Fulbright Award and is about to start a year-long water quality testing project in Burkina Faso. So these are, the work itself is, to me, very hopeful, because we've seen progress from the time of the Millennial Development Goals, and I anticipate that we will see good progress in the years ahead with the new Sustainable Development Goals. And I get to see and do sort of step-by-step work in these various countries. And then I gain a lot of hope from the fact that my students are carrying on this work. Yeah, so I wanted to emphasize what they're doing because it's very impressive to me.
Exciting work. Where's your next trip?
Excuse me?
Well, where's your next trip? Where are you going?
Well, I might be going to Micronesia. My next trip is possibly on a water and climate change project because of the islands going under.
We have a question from our old friend, anonymous attendee.
Yeah.
Is rainwater drinkable without
Yes,
treatment?
yes. So the UN considers rainwater to be among the improved water sources. I mentioned this source in northern Ghana. That's atypical, but more typically, rainwater is an excellent way to collect. I was on a Skype call this morning at 7 a.m. with Uganda, with the area around Virunga, the gorilla park. This is a very highly volcanic area, and when it rains, it all kind of goes into the soil down to infinity. You know, you couldn't put a well into that soil and suck up water. And so rainwater harvesting is an option that we were talking about for this very poor region where there's a enterprise that's growing coffee and looking to improve the lives of the people that are providing the coffee beans. So yes, definitely, rainwater harvesting is an excellent approach. And I don't have it in my slide deck, but we've built at the factory. When we started the factory, we had no power, we had no water, except for that pond down the way, and we needed cleaner water, and we had a big roof on the factory, and so we've built a very large rainwater harvesting system for the factory.
A final question from Lisa Hook. How do you work with or coordinate your WASH-related work with water management? And any suggestions on resources for learning more about the intersection of the two?
Could you just repeat? You were kind of echoing and I didn't hear properly.
So WASH,
yes,
the acronym that you gave us, and water management. Mm-hmm. Is there a distinction between the two? And if so, how do you coordinate that?
Oh, okay. All right. So WASH is just water sanitation hygiene. It's just the acronym for the field of work. And yes, we need to manage water. And I'm not sure what more to say about that. They're not exactly synonyms, but they're definitely related.
Well, on behalf of the MIT Alumni Association, I want to thank you, Susan Murcott, for joining us today. And thanks to the MIT alumni for tuning in. If we didn't get to your question, we'll pass it to Susan after the webcast. And please share other reactions or further questions using the hashtag MIT Better World. And please join us next month for another session of Faculty Forum Online. One last word from Susan.
Yes. So I teach a WASH class in September, and we have an LMOD website, and a lot of the materials like this report will be on that site, and it will be an open access site. So if one looked up my website and my course, they would be able to share in the materials and participate to that extent. It's not a EDX MITx course, but they could participate to some degree.
Well, thank you again, Susan Murcott, and thanks to the alumni for tuning in.